solution for example 4. In this example, I want to show you how to predict output for a second order plus time delay model. And so this model is not new, but I want to show you how to generate the signal, for example, the power signal, using this signal builder in the Simulink. Okay. So in this example, the liquid level in the tank can be described by this ODE, and then RV is the valve coefficient equal to 0.1 minute per square meter, right? And then the A is the cross-section area and equal to 4 square meter, and QI is the inlet flow rate, and then QI change, and here, and from 0.4 to 0.8 at time t to the second minute, and then goes back to 0.4 at the 6th minute. This 6th minute. So we want to predict the liquid level in the tank, and using Simulink. So the first approach, you could decompose, right? Decompose this one as the summation of here's two-step functions, right? But in some of you may feel difficult to do the decomposition, right? So now I want to show you and how to generate and this power signal using the signal builder in Simulink, and then you don't need to do the decomposition, right? So before we do that, and we need to change the ODE to the deviation form, right? So this is a linear model. I believe most of you can do the job. Here the steady state value for QI and H are 4 cubic meter per minute, and also his 0.4 meter. This steady state value QI over bar, H over bar, right? Okay. So here's the deviation equation, and then so QI prime actually equal to QI minus QI over bar, or initial value of QI. So you can see the initial value is 0.4, right? So we minus 0.4 here. This equals 0, right? This one equals 0, and then this equal to 0.4, and this equals 0, right? So therefore the deviation profile of the Q in is 0.4, just 2 minutes, is 6 minutes, right? Okay. So similarly, we're going to get the transfer function first. So I believe you will get the transfer function, just perform Laplace transform on this equation. So Laplace transform here, perform Laplace transform, and then you separate the input and output terms, you could get the transfer function. So so what you're going to do is we just make the transfer function, this transfer function, okay, and then you use the signal builder to build this input signal, and as the input of the transfer function, and then you could get the output and then profile HT from the transfer function. Okay. So here is the step for you to generate the power signal from the signal builder. Okay, let me see. Close this one. So generate a new, find new. Here's a model. This new model. So I close the old model. This new model. And then I save the model as the example 4 Simulink, right? and then I want to get the QI prime first. So I want to get the power signal from the signal builder. So here is how we go to get the signal builder here. So we go to the sources, and then you're gonna get signal builder. Draw it here. Zoom in, make it a little bit bigger, and then double click, and then here this is the default signal. This is the default signal, just like I shown here. So this is default signal, but this is not we want, right? You see, this signal, the magnitude is 1 and the pulse from 4 to 6. Okay, so therefore we need to change. So how we going to change? We need to change the time range, right? Change the time range, and then here in this example, the time range is from 0 to 20. So we put here 20. So here we put 20 here. Okay, and then the second step is we well, here you can see this in the unit in this signal builder is second. This is the default time unit. Well, it doesn't matter. So the unit is depends the time unit. Time unit depends on the model. Okay, even this is second, and in our model actually it's a minute. It doesn't matter, right? Because in the model and we use the in a minute, and we could change this one, but I don't know how to change this one now. I will show you later, but I want to save some time. I'm here. So the second step is after we change the time range, and then we need to change the duration and amplitude for the power signal. So here we could go to the. So what you're gonna do is you're going to select. So use the mouse to select the. So you can see, you select this top line here, and then you can see this red color and dot here, and then after you just double click, double click, so you can see and see now the top line here is in a bold and format, right? See, this line should be in the bold format for editing, and then we could change the time for the left pole here, the time for the right pole, and then we could change the magnitude here. Okay, now I want to show you. So we change here the time for the left pole. We change to the 2, and the time for the let's see, left pole here is 2. If it doesn't allow you to change in this place, and then you could see you move the mouse on the left and line here, and then you could just move it. See, you could draw it around to the pool. See, not easily the 2. So you could change to 2. Okay, and again, double click here, and then you change them, and the right pole here is 6, and then the magnitude here is we change to 0.4. Okay, now we're done, right? The signal is from 2 to the pulse from 2 to 6, and the magnitude is 4. So, but before you move on, you need to check whether the signal is correct or not, right? So tips what I'm doing is I will make I will add I will add a scope here to see whether the signal is correct or not. Right, just run simulation, and the simulation here, because we want to do a simulation for 20 minutes, right? So we change to 20 minutes. Run the simulation here, and then you should see, right? This is what signal look like. See, the pass from 2 to 6, and then the magnitude is 4. So you already generated the input signal. Now, and the next step is to add the, so again, right, you need to check the input signal. Now it's correct. Now you just need to add the transfer function here. The transfer function should be, right, based after you input the RV and A value, you could get the transfer function like this. It's 0.1 over 0.4s plus 1. So you're going to put the transfer function here, and then this is the input signal, right? And then output of transfer function actually is h prime, right? However, what we want is we want to get h value, so therefore we need to add, so this h, you need to add h prime with the h over bar, right? Or h0 initial value, right? Or initial value of h, because h equal to, right, h over bar plus h prime. Okay, so you need to add the h over bar. H over bar is 0.4. Okay, and then you add them together, and then you could save the output in h. At the same time, you add the time and the variable here, the clock, and then you save the time in t. And then you could do simulation for 20 minutes, and then you get the result. Now I will show you. So after we get the input signal, we add the transfer function, go to the continuous category, and then get the transfer function here, and then you type the transfer function here is it's 0.1 of the numerator. Denominator you get 0.4 and 1. So now you get this one. So you link them, okay, and then remove this, and then I want to show you, okay, and then so you're going numerator should be, I forgot the parentheses here, yeah, so you should not remove parentheses, otherwise you can see the value, okay, of the numerator coefficient. And then we need to add add a constant 0.4 here. Add the constant value here, 0.4. So go to get to add the constant, you go to the sources, get a constant, double click, you put 0.4, and then you add the summation from the math operations, add operation, right? Add them together, and then this is h. Then I'm going to save it in sync category, right? You save it here. You're going to get a display, get a scope, and then you get here is workspace, right? Okay, so link them together, and then change the name of the output. Here is h, and the format is array. Okay, but we need to get the time signal, right? So we get the source, the clock, and then again put in the sync, and then save it into the workspace. Double click, change to the time and variable t, and again change the format array, and then link them. Then save it. I think you're ready to go. Save it, and then we just run the simulation, and then you're going to see the profile, what profile look like. So this is what profile look like. Okay, similar to the result I show you in the lecture note. Okay, now you want to plot it, right? Plot the profile. To do that, we go to the again we add a new script, and then you just push Control and S, keyboard together, and save it as the main example 4. Okay, then just type plot th line width 2, and then you're gonna here based on the node, then you're gonna add as label. Here is the time, the unit is minute, and we will use the font size as 12 for the label, for the Y label. Similarly, we could get label H, and the unit is meter, and then the font size 12, and then Control plus S together, save it, and then just type main example 4. See, this is what you should get for the, see, this is what you should get for the output profile. So output profile going up to 0.44 and then going down back to 0.4. Okay, so we are done with example 4.